Hello, everyone. We are presenting our design entitled Gradual Rotary Adjustment on Slope Surfaces, or GRA.S.S. My name is Lewis Weber.
My name is Jim Roebuck.
And my name's Margie Peeler.
We'll start off with a bit of background information on rotary cutters. A rotary cutter is similar to a lawnmower, but it is pulled behind a tractor and is able to clear much thicker and taller brush. A rotary cutter is also able to cover much more area in a shorter amount of time than a typical lawnmower would.
While rotary cutters do make the lives of farmers and landowners much easier, there's a flaw in some of the models that our project is attempting to address. So rotary cutters and tractors are fixed together with a semi-rigid linkage called a 3-point hitch, and that's seen in figure 1 on our poster. Because of this 3-point hitch linkage, the cutter and the tractor move together as one body. This becomes an issue when the tractor transitions up an incline or down a decline while the cutter trails behind it. As the tractor transitions down a hill, the cutter is lifted up into the air, leaving a patch of uncut grass or brush. And then as the tractor transitions up a hill, the cutter is pushed down into the ground and the blades often scalp the grass. And this issue is seen in figure 2. Lifting and scalping, they present a number of issues. First, they reduce the usability of the land. Those really tall sections of grass that are left uncut when the rotary cutter lifts off the ground are more difficult to walk or drive over. And then if the rotary cutter scalps into the ground, it often ends up killing the grass that was growing in that spot. And that can cause erosion or poor soil health.
Secondly, no landowner wants to look out onto their field and see patchy sections of tall grass and unsightly divots of dirt where the rotary cutter scalped the ground. Additionally, landowners do not spend more time to go back and mow over uncut sections. Our design problem impacts a specific population of landowners who are maintaining land with undulating terrain similar to that of East Tennessee. Our design targets individuals using Category 1 tractors with an engine power between 20 and 40 horsepower who are also using a 5-foot single spindle rotary cutter.
Our client stated that he wanted a, quote, clean cut field. And overall, our goal is to reduce the amount of lifting and scalping while mowing to produce that evenly cut field.
We were able to accomplish this goal by replacing the standard rigid top link of the 3-point hitch with a hydraulic top link. We then connected the remote hydraulics of the tractor to our separate hydraulic system, which can be shown in figure 3. This separate hydraulic system allows for the rotary cutter to conform to the terrain it is traveling over. We like to refer to this condition as being in float. In float, the rotary cutter's movement is not restricted by the top link and is able to follow the undulating terrain without lifting or scalping. Our design has 3 main components that allow for the system to work in float mode. These conditions are the hydraulic top link, a piston accumulator, and a solenoid valve. The hydraulic top link is able to extend and retract as needed when the top link is in compression or in tension. We added a piston accumulator to the design to account for the different volumes on each side of the hydraulic top link. One side has a rod while the other does not. The accumulator stores the excess hydraulic fluid when the top link is in compression. It also provides necessary fluid when the top link is in tension. Both of these conditions can be seen in figure 4.
So lastly, the solenoid valve allows our hydraulic system to switch between being in float and then also acting as a rigid top link. When the solenoid valve is not powered, it's closed and the operator is able to retract the top link as well as lock the top link in place. And that way they can transport the rotary cutter or lift the rotary cutter up And then in this way, our design doesn't take away any of the functionality that a traditional top link would have.
We marked a test track that's as close as possible to the requirements detailed by the client. We then surveyed and generated a 3D model of the testing site using MATLAB, which can be seen in Figure 5. To test the success of our design, we used Vernier video physics software to track the movement of the rear wheel on the rotary cutter. The two pictures in the results section were taken at the same point on the track. In the photo on the left, a rigid top link was used, and you can see the rear wheel is lifted off of the ground. In the photo on the right, our system was employed, and the rear tail wheel is still on the ground. In these last two graphs of the tail wheel height relative to the horizontal position on the track, you can see that our solution successfully reduced the amount of lifting and scalping.
Thanks so much for listening to our presentation. We had a wonderful time working on this project, and we hope you enjoyed learning about it.